document indexing. Document indexing is the process of associating or tagging documents with different search terms. In this lecture, I will consider the index construction, scaling of the index construction, sort-based index construction, and BSBI, blocked sort-based indexing techniques. For index construction, the starting step may be parse the document and extract words. For example, this is document 1. So first we will extract all terms like there, are, and assign document ID with them. Similarly, for document 2, we will repeat the same action and assign the document ID. This is the simplest part. Now the next part will be term document indexing. Actually, in this indexing, we can easily find that some terms are common in both documents, like hurricane and Drew, both are common. This, if you maintain term ID and document ID as a separate entry, then such repeating terms may increase the disk space and increase the time complexity also in any document related computation task. So first process may be term document indexing. In this case, we will write the term and then assign the documents in which that term occurs. For example, there occurs in document ID 1. For example, the term there occurs in document ID 1 and doesn't exist in the document ID 2. So I will put here document ID 1, R exists only in document ID 1, but there are some terms like hurricane exist in both documents and Drew exist in both documents and they exist in both documents. Sandhya exists in both documents and like that. So now this construction is called term document indexing. We will take terms and assign the documents or document ID. Generally, document ID is used to represent the indexing. Now the scaling issues in index construction. The main problem is the size of main memory. Actually, the size of main memory is very limited and we cannot keep entire data into main memory. And if we take data from disk and then prepare the indexing, then it will take a lot of time. So now the problem is because there is a huge gap in speed between main memory and disk. Means the access time from main memory is very fast, while access time, it takes a huge access time with to access the data or access the data from disk with respect to main memory. So this is the main issue which creates, this is the main problem. So how can we construct an index for very large collections? Means large collections means we cannot fit that data properly into main memory at a time. So how can we manage? The best is the best way maybe the optimal use of hardware resources, means how can we optimize or how can we manage the use of disk and main memory in entire operation. So the success of and speed of entire operation will depends upon this management, and all such algorithms just try to apply optimal use of hardware resources for index construction. The first is the sort based index construction. In sort based index construction, the first step is parsing and index construction, and second is sorting, and third is merging. It will clear from here. Suppose we take millions or billions of documents and we need to prepare such kind of index, like term there exist in how many documents. So making such indexing by taking one or two documents is very easy, but if you have billions or trillions of documents, then the some optimization techniques or optimal methods may be necessary. So index construction, the first step is parsing the index construction, second step is sorting, and third step is merging. Now we will go through some issues like parsing index construction related issues can be solved easily. We can handle one document at a time, or we can distribute the task. For example, we just as here I have taken that we will take one document at a time, and then another, and then we can merge them, and we can distribute some documents to some machine, and another documents to another machine, like that. Now the main issue is sorting the term document indexes is very crucial issue. In memory, sorting is not applicable as we cannot keep whole data into memory at a time. The use of disk seek may be very time consuming. Actually, in traditional magnetic disk, suppose data exists here, and head rotates and pick data from here, then it is not guaranteed that next head may find the next data here or here. It may be possible that next data exists at this point. So data doesn't exist in a sequential fashion, may not exist in a sequential fashion, that will require for the sorting or disk seek based sorting operations. So in this case, if data exists at this point and this point, then it requires a complete rotation instead of a just a recent sequential move. So it will be very time consuming, and if there exist several such kind of operations for sorting, then system will start paging and it will take a lot of time. There exists some external sorting technique like merge sort, etc. May be suitable option, but also have some bottlenecks, like a random disk seek is slower than sequential disk seek. Like here, sequential disk seek means suppose at the starting time point exists here, and then point exists here, then point exists here, then here. Then head will take one move, and it can search the data, and then data accessing or searching, fetching will be fast. But suppose one data exists here, one exists here, and one exists here, and then again another exists here, then it will take a lot of random move or lot of head moves, and it will increase the time. So this is a major bottleneck of the external sorting techniques like merge sort, etc. So now what will be the another option to handle such kind of situation? So the best thing is the BSBI, block sort based indexing, sorting with fewer districts. Actually, the algorithm parses the document into term ID and document ID. Parses the document into term ID and document ID pairs and accumulates the pairs in memory until a block of fixed size is full. We choose the block size to fit the comfortably into memory to permit the fast in-memory sort. Now, if we use block of some suitable small size, then it is possible to fit that block into main memory, and then sorting algorithm will work faster. The block is then inverted and written to the disk. The inversion is a two-step process. For example, here, this is a memory block. First, we sorted the term ID doc ID pair according to the term. The block size is small. Here it is just taken 4 terms to explain the system, but it is possible to take 10 MB, 4 MB, or some appropriate amount that can handle your system, that can be easily handled in the system's memory. So first we will sort this entry according to the term, and then we will take another block and then sort, and the next task is to merge them. So here births occur in document D3 and D2. So this is the merging. In merging, we maintain the complete sorting of terms. In the final step, the algorithm simultaneously merges the blocks into one large memory index or merged index. So now, for example, we have a 12 byte long entry, then we can easily divide the record into 4 byte entries like term, document, and frequency. Now we will repeat the same process for multiple documents. Now sort, suppose we have a 10, then search 12 byte records by terms. Now we define this separated as a block. Here it is taken 10M. We picked this example from book that I referred, and now we think that it can easily fit into memory, and suppose we have 10 such blocks to starts, then the process is very similar like that. We will pick one block, sort their entries according to term, take another block and then merge, and then put into a final index. This is the pseudocode. while at a starting at n is equal to 0, while all documents have not been processed, do n is equal to n plus 1, take another documents and then prepare a block by parsing the documents. If block is full, then parse next block, then take a next block and extract word, term or document ID pair from documents and put in the next block and repeat this process till the end of all documents. Now the next step is BSBI invert block. Now in this case we will take BSBI invert blocks, means we will take term and then document ID, and then we will sort that block according to the term ID and then write block to the disk. Then we will write the blocks to the disk. This is the merging step. We will take one by one. We will take the block pairs and merge them and then write back after preparing the index. This is the analysis of BSBI algorithm. Parse documents into term ID and document ID pairs until block is full. Invert the block. Inverting means take term ID and identify in which documents that term exists. Sort the term ID document ID pairs, write the block to disk, then merge all blocks into one large POSIX files. Now go through this example. Actually here we used term directly, not used term ID. In BSBI algorithm, the algorithm converts term into term ID. For example, suppose we use write this as a term 1, this as a term 2, this as a term 3, term 4. Then there will be a different term IDs, and the system will handle document ID and term ID only. Term ID and doc ID. But the problems are not, it need two copies of the data on the disk, input and then output. Dominant term is O n log n. Actually it will require n log n operations, and n is the number of term ID and document ID pairs. But in practice, parse next block takes most time. For example, suppose this is our starting block and this is the next block, and it is very tough to identify the next block. Means not tough, it is the problem is such kind of algorithm maintains a dictionary, and parsing the next block means suppose you start another block. After parsing this block, when you start this block, then it will take a lot of time because we manage a dictionary. And when such terms occur, suppose this term exists, then after this existence we will search the occurrence of this term in dictionary and then provide some index. After that we will search whether this term exists in dictionary or not and then provide some index. If not exist, then we will provide new index. If exists, then we will fetch that index. This is the most time killing process of BSBI algorithm. Now the next part is disk seek times versus memory access time. It is not always feasible that or possible that we can put or we can keep entire dictionary into memory. So the disk seek time, so we will manage some data into disk and some data into memory, and then again it will create the differences. Now the another thing is applying merge sort. Can we do binary merges with a merge tree of log base 2 layers? Another thing is during each layer, read into memory, runs the block of 10 M size and merge and write back. This is a simple merge sort techniques that we can apply with BSBI algorithm for merging that fetch both pairs from disk, then apply merging, and then this is the merged disk, then we will write back into the disk. Now again some issues with merge sort based indexing. It is more efficient to do a multi-way merge where you are reading from all blocks simultaneously, providing you read decent sized chunks of each block into memory and then write out a decent sized output chunk, and then you are not killed by the disk 6. Our assumption was we can keep the dictionary in memory. We need dictionary which grows dynamically in order to implement a term ID mapping that I already discussed. Another thing is actually we could work with term document ID posting instead of term ID document ID posting. It can also save time because at that time we can save our memory space that is killed by dictionary which maintains term and term ID. But then intermediate file become very large and we would end up with a scalable and with very slow index construction method. So how to solve these issues? Now this is the reference. So till now we solved some issues like how to handle the random disk seek which exists in general general random sorting or random disk searching based techniques, sorting techniques. Another thing is we get this information that we can use external sorting, we can apply BSBI technique, but still there are some problems with BSBI based techniques like it uses the dictionary which grows dynamically into the memory, and other thing is due to such kind of dictionary the creation of parsed block which is used in this technique is slightly tough. Now to reduce such kind of problems, if we remove the such kind of dictionary, use need of such kind of dictionary and directly apply term and document ID, then it still creates problem. So till now we have solved some issues, but still there exist some issues. So in next lecture we will try to solve this.